Hello everyone, welcome to the channel. Today's question is implement trie. If you are new to the channel, please consider subscribing. We solve a lot of interview questions on this channel and that can definitely help you with your interview. The question says we need to implement a trie with three functions and the functions are insert, search and start with. And if you look at the example, we are given with a trie and we need to insert apple. And if we search for apple, it will gonna return true. And if you wanna search for app, it should return false because we don't have any word app, but we have apple. We don't have app. If I begin with start with app, that means I'm searching for a word which start with app, and we have a word which start with app, which is apple. In that case, it will gonna return true. And if again I will gonna insert app, after inserting and now I search for app, then in that case it should return true. The question is asking us to implement the trie. So let's talk what is a trie. Trie is a tree-like data structure which is usually used to store words or string of words so that we can search for the word efficiently or we can look up for a word with its prefix. And when we are saying trie is a tree-like data structure, so it's have a root. And the root have a dictionary and a boolean value. Dictionary is to store the parent-child relation and the boolean is to check whether the word ends here or not. So we have a dictionary and a boolean value, we can say end here, which will gonna be false. And if I take few words like ABC, MNO, XYG, and let's take MNP, and we need to store these words. So if I'll start with root, initially it will gonna be empty and it will gonna have a boolean of false. That word does not end here. So we start with A, we added A and we increase this to here. Now we come to B, we added P and the word is not ending here. So we move ahead and now we come to C. And we found that the word ends here. Make a new node which will show true and empty. Now I came to M. So again I will start with root and I checked we don't have M here. So we will gonna store it here. So we added M and the word does not end here. So we'll make another node. I come to N and again I will store N and it does not end here. I come to O and in the same way I stored O and word ends here. Then I come to X, again I will start with root and I stored X with a boolean F that the word does not end here, and then I come to Y, I stored Y, then again the word does not end here. I come to G, I stored G and I have true at the end because the word is ending now. Now again I come to M and P. So I came to root, I checked, we have M, okay. Then I come to N, we have N, okay. Then I checked for P and N goes to O, not to P. Then what we're gonna do? We'll again gonna make another node and I'm gonna store P and then the word ends. So if I will ask that hey search for ABC. So it will come to A, then it will come to B, then it will come to C, and at the end it shows the word and it will say yes, we have ABC. And if I say that do we have any word which start with AB, then it will come to root. It will check whether we have A. Yes, we have A. It come to B, and yes, we have B, and my string ends here, and it will return simply true that yes, we have a word which start with AB. So this was the main structure look like. Now you look at our specific question. So we have to implement insert, search, and start with. As I have told you that it's a tree-like data structure, for that we need to make a tree node. So we will make another class with the tree node, and in that we will simply pass init with self as we will gonna be our value. So we can simply say, or we can write value self dot value equal to value. Then we'll make a dictionary which will gonna be our children and which will gonna be empty in the starting whenever we are making a node. And I will make a boolean which will gonna be check whether the word ends here or not, and it will gonna be initially false. So this is our tree node which you are making every single time, when we are adding a word. And so we add some value, we have a children, and we have a boolean whether it's ends here or not, and which will gonna be initially false. So we are done with our tree node class. Let's move on to our trie class. In this we will simply, because we already have defined our tree node, then we can use our tree node, and simply our root will gonna be tree node, and it will simply gonna be, for now because we don't have any value, a empty dictionary with a boolean value false. And if we come to our insert function, first of all we will take our root, and then we will gonna take a loop through our word, and we will take enumerates with I and the character in the word. And if the character is not in the children, then what we will gonna do? We will gonna insert it, and before we will gonna insert, we will make a tree node, or you can say while adding it there, we will gonna make a tree node and then we will add it. We will add children char, which will be equal to our tree node, and we will pass the char as a value. Now I will treat the next whatsoever with our tree node as the root value. So initially we can start with something main. So main is equal to our self.root. So here also we have to write our main dot main dot children. So now our main will be equal to main dot children, because if you see in the example, once we came here, again I have to check down. So again I will perform the same logic what we did here to check it. So that's why I made the main equal to main dot children, so that we can move ahead and we can keep checking. And if I is equal to the length of word minus 1, that means we reach to the end. That means if we talk about this specific example, that means we have reached to the end. So what we will gonna do? We will gonna make our main dot end here equals to true. So what we are doing in the insert function, first of all we are looping through the word, the given word we have. We will check. So if we take about this example, ABC, and suppose we have ABC and we have to add D. So I took a loop through ABCD. I came to A. I check in the its children whether B is there or not. We have B. Then I check for its children whether C are there or not. Then I came to C. Then I check whether we have D or not. And we don't have D. So what I will gonna do, I will make a tree node of D. And it will become D and F. And why F? Because in the tree node, we are taking it as a false. And once we reach to the last element, we're gonna make our end equal to true. And here equal to true. So this is what we're doing here in our insert function. So this was our insert function. So let's look for our search. So again, I will gonna make a main which will be equal to self.root. And before we write the syntax or the code, let's move to the example and let's see how we're gonna search for something. So suppose we have A, B, C, D, F. Or you can say we have A, B, C, D. We start from root. We have A. We move ahead and I will come to the children of A. Again I will check whether the children of A have B or not. Yes, it have B. We will move ahead and we will check for its children, means children of B. And every time here we are treating it as a root, here we will treat it as a root, because again I'm checking it for a children. Or you can say if not root, then we can write we are treating it as a parent. So again we are checking for the B's children, whether B's children have C or not. Yes, it have. Then again we will check for D. We will check here. Again we have D here and we are checking in the C's children. And if everything is fine here, then we know after coming to do, we have changed our end here to true, because when we were inserting ABCD, after coming here, we made our end here equal to true. So if we have everything, so at the end we will gonna return our end here. And suppose we have to search for ABG. So I started with root as it have A. Okay, then I will check for its children. It have B. Then I will check for the B's children. Does it have G? No. At that very moment, I will gonna return false. So let's write it down here. I've taken main as a self to true. Again, I will take a for loop in word. And if char is not in children, or you can say main dot children, or you can say parent dot children. So I will simply gonna return false. Else, if it have in its children, then what we will gonna do? We will gonna make the child as a parent. So our new main will be equal to main dot children. And we will keep doing that. And if the end, we reach to the end, we will simply gonna return main dot end here. And if we have whole word there, so at the end, our value of end here is always gonna be true. So search was when we are searching for a whole word A, B, C, D. What if I just want to search for A, B? For that, we just need to, rather than returning main dot end here, we will simply gonna return true. So start with, again I will gonna take main as self dot root. Again I will gonna take a for loop in prefix, because we are not given with the whole word, we are given with a part of a word, and which is prefix. Again I will suppose we are given with AB. So if we look for the example, I will start from root, we are given with AB, we have A, I will check for its children, we have B there, and that's it. That means we have a word which start with AB. So we have taken a for loop in prefix, and if character is not in children, and whose children? Main dot children, then we will gonna return false. And now, because we have to traverse down to the next children, so again we will modify our main to the main dot children. And because we have written this condition, so if the character is not in the children, that means we will gonna return false. And if the character in the children and we end up with our string value or the prefix, then at the end we can simply return true. And if we check for this line of code in our example, so suppose I have AD as a prefix. So the question is asking that look for whether we have a word starting with AD. So I came to root, I have A, I will check for its children. So its children is B, and B is not equal to D. So I'm simply gonna return false. So these were the three main functions we have to implement: insert, search, and start with. So in the search, we will gonna search for the whole word. So at the end, we are returning the value of end here. And in the start with, we are just searching for prefix. So we are just returning false if it's not in the children, else we will gonna return true. And we have discussed about insert, how does it works. We are simply checking for the character, and if it's not there, we are making a tree node, and then we are inserting it there. And at the end, if the length of the word reaches to length of word minus 1, or you can say if we reach to the last element, then we can make our end here equal to true. So these were the main three functions. So let's move to the coding part, and let's see what is the code for this problem. So let's look at the code. So as we have discussed on the pen and paper session, we are making a tree node, and we have a value, and we have a children, which is an empty dictionary, and we have a boolean, which is end here, which is false initially. So if we talk about our class of trie, so initially we just have our root, which is a tree node, and that means it does not have any value, and it contain a boolean which is equal to false. And if you look at insert function, so we are starting with a parent. So I changed the main to parent so that it can be more easy to understand. So our parent is self.root. Then I'm taking a for loop in the word, and I'm checking if the character not in parent.children, that means we will make it a tree node. And now we're gonna make our parent equal to the children. And then we will at the end, if I reach to the last index, that means my end here is equal to true. And if we talk about our search function, so again we are starting with parent, which is self.root, and again we are looping through the word, and if the character is not in the parent.children, we are simply going to return false, else we're going to move ahead, and again we will going to make our parent equal to the children, and at the end we will going to return the value of end here, because in the search we are looking for the whole word. And if we come up to start with, the only difference in start with and the search is that in the search we are looking for the whole word, and in the start with we are looking for the prefix. So simply we're gonna again we will gonna take parent as a self.root, we will gonna loop through the prefix, and then we will check if the character is not in the parent.children, we will gonna return false. And again, and if that's not the case, then I will gonna make my children equal to my parent, and then at the end I will simply gonna return true. So this was the code. So let's check whether it works or not. So here I submitted my code, and it got accepted. So this was the code. I'm pretty sure you are clear with the question. But if you have any question, please feel free to email us or leave a comment in the comment section. I will try my level best to help you out. If this video was helpful to you, please give it a thumbs up. Thank you so much guys for watching the video. Please don't forget to subscribe.